Security groups and network access control lists. I ran into something about a month ago that by the time you hear this may be commonplace, but right now it's brand new. It's called ransomware. Essentially, somebody receives an email, says, hey, you've got an eFax or something like that, and they open it, not realizing eFaxes don't come in zip files. They run the file, and it comes up with a nice little prompt saying, hello, everything on your computer has been encrypted and is now inaccessible. Please follow the process to get your information back. And indeed it has. Everything on the computer, every network drive, USB drive, everything that they have access to gets encrypted with AES encryption, and they upload the private key to some faraway website. And the process is very professional. You walk through literally a wizard where they say, oh, well, just to prove that we can do this, go ahead and upload one of your encrypted files and we'll send it back to you unencrypted. And they do, and you go, wow, thanks. And then they say, oh, and by the way, you need to pay us $1,000 in Bitcoin to get the private key to unencrypt all your files. And by the way, if you don't do that, in 3 days the price doubles. In 6 days, we're going to delete the private key and your files will be inaccessible. It's not pretty. It's not getting any better in terms of security. It may be masked by a lot of the virus scanners and everything else that's out there, but it's getting pretty darn nasty. And that's what we're going to focus on in here is one layer of security for the system, security groups and network access control lists. Here are your do I know this already questions. So read them over. If you know the answers, you can move right along. Otherwise, let's get started. Well, before we get into any detail on security groups and NACLs, or network access control lists, I want to talk about where they're located. I'm on Amazon Management Console. I'm going to shoot over to VPC, and right down here in the security section is NACLs, or network access control lists, and security groups. Now, there is security groups available in EC2 Classic, kind of the no man's land networking that came with Amazon by default for years and years and years and years. But if you're going to do anything serious with Amazon, you're going to use the VPC. So I'm going to, for this nugget and any security moving forward, assume that we are using VPCs. Well, what's the difference? Security groups are kind of like personal firewalls for your instances. So for example, I could create a security group called World Wide Web, and that security group could allow port 80 TCP and port 443 TCP, which is what? HTTP and HTTPS respectively. So I could then take that security group and apply it to an instance, and those two ports or services would be allowed into the firewall. Now, let's talk about the details of that. 155 default rule. What does that mean? It means you can have 100 security groups per VPC. You can have up to 50 lines in each one of those security groups. I'll just put lines right there. And every instance, so if you have a server right there, you can apply up to 5 security groups to that instance. That's a little bizarre to people because they think, okay, I have a firewall, right? And the firewall is the list of rules. Well, in this case, you can have almost 5 firewalls or 5 security groups. So maybe I have a security group called World Wide Web. I've got a security group called, let's just say SSH, and that allows TCP port 22, which is SSH. And maybe let's just be a little wild. We'll have TCP port 23, which is Telnet, which I'll put SSH/Telnet as the name. I could then apply both of those, and it has the effect of combining those rules together, up to 5. Now, these values right here can be changed if you contact Amazon and give them a reason for doing so, but they will tell you right up front, be careful, because you can impact the performance of your instances the more of these that you apply and the further that you increase the limits. Now, these security groups, and one of the big notes is allow rules only. When you think of a security group, think about it like this. Imagine it's almost like got this, so your security group is sitting right here, and it's got this line at the bottom. It's like water. And at the under the water is deny everything. I'll just put deny all. So a security group, when you first create it, by default will deny all inbound until you allow. So, anything that's trying to access this will just fall into the water in the deny all. But as soon as I take this first one and apply it, I say, okay, I'm going to put the www security group here. It will start catching the TCP port 80 and the TCP port 443 before it reaches that deny all. So it's like, oh, you'll be permitted and you can get through without falling through to the deny all, right? Now, one of the things to be very careful of is this other rule. Security groups allow all outbound until you allow. And I know you're like, I think you said that wrong, Jeremy. until you deny, right? No, until you allow. Because security groups can be applied inbound, I'll just put in, and outbound to each instance. And I always tell people, just be the instance. If you have trouble with the directions, I know I do sometimes, and say, okay, inbound from what? Inbound from the internet, inbound from my server, inbound, well, like, what's the perspective? Be the instance. Like, I am standing here, I am the instance, so inbound to me, the instance. So when I set up a security group, by default, it allows all outbound until I say, you know what, I'm going to allow, let's just say, HTTP out, right? In that direction. Well, then what happens is the security group goes active on the outbound, and you have this same thing where it says, okay, well, TCP 80 will be allowed, and then everything else will be denied. An empty security group, or essentially no outbound filtering rules, means that we allow everything, right? It's kind of a different perspective, and think about the mindset of that. Usually, we trust our own instances. Usually. So everything's allowed out from those instances unless we put some rules on there. Then it's like, oh, okay, you don't trust your instances, so tell me exactly what's allowed and I'll deny everything else. Now, fourth one, security groups are stateful. Outbound responses are always allowed. Now, what do you mean by that, Jeremy? What I mean is if the server requests something from, let's just say, the internet, it's always going to allow that back in regardless of what the security group says. Remember, the security group is only allow rules. So if this guy, let's just say, goes to the Windows Update, I'll just put WU. This is a Windows machine, and it's going to Windows Update to download the latest patches for the operating system. I do not have to go to the security group and create a rule to allow Windows Update back in because security groups are stateful. Outbound responses are always allowed. So when something is responding to an outbound request, so outbound, I should say outbound request responses, that just sounds confusing, it will be allowed in. Now, that sounds great, right? Because you're like, hey, well, that allows me to go, update Flash and Java and everything without having to remember to add those IP addresses to my security group. That is good. And I will say it is good, but keep in mind, go back to the very example I used to start this nugget with. The ransomware, the one we ran into was CryptoLocker. If you've heard of that before, essentially encrypts the whole thing. Well, you know what? That would be allowed if you didn't have some other layer of security there. If I ran that program, it would go out, meaning my instance would go out to whatever ill-willed website would get those encryption keys. I mean, it could be a remote control bot. It could be whatever that takes control of my instance, and the security group will just stand by and watch because my instance is requesting all of that stuff to come in, which tells us, once again, that security is a layered approach. Security groups don't solve everything. Instances in the same security group can't speak unless allowed. This is a big misconception. I had the impression initially when I got into Amazon Web Services, oh, well, if all these instances are in the same security group, they should just have full access to each other, right? No. Remember, this is applied to the individual instance. So if I create the www security group and I have, let's just say, 3 servers that I apply to that, these 3 servers don't somehow get a special exemption because they are all in the same security group to fully access each other. They will pass through the same filters that everybody else passes through because the security group is applied to the individual instance. The default security group allows traffic from other security group members. That's probably where the misconception right here comes from, is if I don't select a security group, it will use one called the default security group, and that does allow full access from other members of the same subnet that it's in, right? So they will be able to do that full access, and that's where you get that false impression that instances can speak if they're in the same security group, but that's not the case. It's just the default one has a allow rule for all devices in that subnet. Last thing is that destination port filtering only. Security groups do not do source port filtering. I know if you are a firewall admin in your past, you're like, oh, I do source and destination port and all that kind of stuff. This is not designed for that. This is very simple security. NACLs is where you can start getting fancy. Well, let's look at the configuration to help fill in the cracks of security groups. I'm in the VPC, click on security groups, and I see all the security groups that I've created here. Notice the default one at the bottom. Take a look at this guy. If I look at the rules, it says all TCP, all UDP, ICMP, all ICMP, which is essentially everything, and all ports of them from the source security group, which is this security group. So essentially, if you assign something to the default security group, it's allowing everything from other members of that security group. That's the default permissions. Now you'll notice when I create a different security group, so I'll click on create. Let's just name this HTTP and HTTPS. Pretty good description. So I'll just copy and paste that in there. I assign it to my, oh, I forgot that I deleted the VPC. Please hold. There we go, simple fix. I'm going to go back down to the security groups. Oh, and I can see it added another default security groups for the VPC that I just created. So I'm going to create a security group this time, and we'll call it the HTTP, HTTPS. I think it's still on my clipboard, so I'll just paste it in there. VPC, and I'll select the my VPC that I just created. Hit create, and it's going to start off by default blank. So I have a empty canvas to start painting my rules in. You can see outbound or inbound and outbound rules. Outbound allows all traffic to that destination, so until I add something, everything will be allowed. Inbound rules, I don't have anything, so nothing will be allowed by default. So I'll click on add, and I have the option. I can either say I want to allow TCP port 80, or I can do 80 through 1000, whatever ports I want to put in there. I'll just put 80 from a source of, and you can see it by default, it automatically pops up the common selections of other security groups. I'm going to say 0.0.0.0/0, which is the everything. So essentially, I'm allowing port 80 from everything, and then I can add another rule. Now, an easier way of doing that, or at least less typing, is I can just hit the drop down. I know I'm off the bottom of your screen, and choose HTTP. Oh, wrong HTTP. They have two HTTPs. One's 8080, which is a typical proxy port number. There's my HTTP 80. You can see it just saves you one step of typing in the port by doing that. They have some common ports in here. Or you can go in and select your TCP or UDP, or even a custom protocol rule. This is where I can select protocols other than TCP and UDP, which some people don't even know there are other protocols. There are other protocols like OSPF, routing protocols. You can see there's quite a laundry list of other things out there. So Amazon has allowed that as well. But all I do is add in all of the rules that I want and what source they are allowed from. That's it. That's creating the security group. I can save that. So I'm allowing web and, oh, I didn't finish putting in the destination. I was going to say some unknown protocol into my system. Then I just go through and apply it to the instances. So behind the scenes, I just spun up an instance in my VPC. I named it SG Test. So I'll click on that, and by default, if you just go through the Launch Instance Wizard, which most people do, it will create a security group called Launch Wizard blah, and put in a number there. Based on the kind of instance that you spin up, whether it be an Ubuntu, Linux kind of instance, it'll choose port 22 to allow SSH management coming in from anywhere. If you use Windows, it'll be Remote Desktop Protocol. That's TCP 3389 from anywhere, just so you can manage the PC, and they expect that you would remove that or at least modify it later on. If I want to assign it to a security group, that's where I can right click on the instance, hit change security groups, and notice I can check them. So I can add 2, 3, 4, 5, however many security groups, well, I should say however many, up to 5. Right? 5 is the maximum per instance, and because it starts running into performance issues, I hit assign, and now I've got multiple security groups assigned to this. If I hit view rules, they've got a pretty sweet display that shows exactly which security groups are allowing which permissions. I just realized I have HTTP and HTTPS that's only allowing HTTP, but you get the idea. That's how you configure security groups. Now let's turn our attention to the Network Access Control Lists, or NACLs. These are exactly the opposite of security groups. First off, they do not apply to individual instances. Security groups are kind of like personal firewalls, but all the instances sit inside of a VPC subnet. And by the way, NACLs are a VPC only thing. They do not apply to EC2 Classic. So the NACLs sit right here. Or you might remember earlier I drew up a diagram. This would be earlier in the series where I was talking about the architecture of VPC. Drew up a diagram that showed a router on the outside of that subnet. That's where the NACL applies. So it applies to all instances for inbound and outbound traffic. Because it's so significant, I'm actually going to jump to the last statement first. NACLs are stateless. Outbound is always filtered. Inbound is always filtered. They are not smart. These are like the firewall rules that we've all come to know and love if we've been into firewall rule before. I say HTTP is allowed from all. No inspection other than, okay, are you coming in on port TCP 80? You're allowed. Or are you going out on TCP 80? You're allowed. Otherwise, you're denied. I don't do any kind of stateful like, oh, well, did you request this? No, no, no. Bam! Allow or deny. It's very simple security, and sometimes simple is what you need. They're really just a list of rules where the lower numbers are processed first, and it will stop on the first match. It also allows, let me jump right here, permit and deny. So this is when I say it's exactly the opposite of the security groups. You can see these are like counter flip side to it, and you can tell why. There's a lot of times you need to be able to type in a deny statement. For example, you've got, let's just say the 150.5.0.0 subnet that's allowed in, and then all of a sudden there's one IP address in that group that starts trying to hack you, that starts doing a denial of service attack, or there's a group over in a certain region of the world where you're like, not those guys though. So I might want to permit the whole subnet and just deny maybe 150, you know, wherever that region would be, 150.5.100.0/24 would be denied while everything else is permitted. Now, the way this processing works is as the packets come in, it says, okay, are you 150.5.100.anything? And the packet says, no, I'm not. It comes down to the next one. It says, okay, then are you 150.5.anything? Because it's a /16. It goes, actually, no, I'm not. Well, if I'm out of rules, then there's an implicit deny at the very bottom. So you will be denied. So it's kind of like, well, you better match something. Either this, and I'm going to deny you anyway, or this, and I'll permit you. But if you don't match anything, I will deny. Now, let me say this. Every subnet that you create in VPC has a NACL by default, which might make you scratch your head if you consider that. You go, well, I haven't allowed anything and they deny by default, so why is everything not just denied by default? Well, Amazon knew we would all ask that question, so they said, you know what we've done, because we know not everybody needs NACLs, we're just going to put a default NACL on every single subnet, and the inbound and outbound rules will both have Rule 100 to start off, which you can modify, which allows everything from everywhere. So essentially, by allowing everything from everywhere, NACLs aren't even in the picture until you come in and start editing and modifying these rules. So I can say, well, actually, no. And I want to start adding my own rules in there. That's where NACLs really start engaging and everything starts filtering through whatever rules that you apply. And they even want to make sure you catch that. Allows all inbound traffic. That's that rule right there. Because network access laws are stateless, you must create inbound and outbound rules. That's how it's filtered going through. Okay. Did I catch everything? Default NACL rule, deny all, circumvented by the default, allow all rules, separate inbound and outbound. It is one NACL per subnet. So I can come in here, let me just show you this. So I can see this default NACL, which allows everything, is associated with my 172.16.1 subnet right there. If I create another one, I'll just call it ASDF and create it. Says the VPC it's associated with is the VPC, but when I go to assign it to the subnets, I notice no subnets are there, and I go, okay, well, I want to assign it. Well, let's add it to 172.16.1, right? It's like, oh, so you can assign multiple. Nope, as soon as I do this, as soon as I say, okay, I've got a new ASDF NACL, you'll notice that it removes the association of the default NACL. And now, it's got just ASDF associated with the subnet because only one NACL can be associated with it. Last thing I'm thinking of is, well, how many NACLs can I have, or how many rules can I have per NACL? I'll take you straight to the Amazon source right now, and again, these are always changing, but you can see network ACLs per VPC, 200. So I can have a bunch of them, but remember, you can only associate a NACL with one subnet at a time. But look at this one, rules per network ACL. the sum of the ingress and egress rules, whereas the limit for ingress is 20 and the limit for egress is 20. So they're saying 40 total. Now that could be significant, 20 rules, and they're doing that for performance reasons. The more NACL rules you put into place, the more significant impact it can have. And remember, Amazon is using software-based filtering for these NACLs. They're using, they're not every time somebody creates a NACL, it's not going out to a Cisco firewall equipped with ASICs and all that kind of stuff to do this filtering. They're using software-based firewalls, I think, because Amazon will never tell you. But at the same time, when you look at these rules, you go, wow, only 20 rules? Well, that tells you that they're doing that because it will have performance impact. Oh, one other thing I just popped in my head. When you're looking at these rules, and let's just look at ASDF, and you add a rule in here, you'll notice that it comes up with a rule number. So it says, for example, 100, 200, or 150, or whatever rule number you want. This can be anything from 1 to 32,768. It's a binary thing, right? So I can type in whatever rule numbers I want, but remember, it processes through the lower number rules first, right? So you want to put your most common matches at the top, and you want to leave yourself some space. You don't want to do rule 1 and then the next one rule 2, rule 3, because if you ever have to squeeze something in, it becomes impossible. Like if I want to put something between rule 1 and rule 2, I actually have to delete rule 2, kind of move everything down. You don't want to do that. So Amazon recommends putting gaps of 100. So start with rule 100, your next rule will be 200, 300, and so on, so you can always squeeze something in between. And there is security groups and NACLs, both the concepts and configuration. I hope this has been informative for you, and I'd like to thank you for viewing.